Okay, so today's class will start with entity relationship diagram. So we use this tool to draft out our database, right? Once we've learned about this tool, we'll talk about the project and what we are expected to achieve. So, what are entity? You can take notes. I will try and send this to the Telegram group after the class. An entity relational diagram is a visual tool used to model the structure of your database. So an entity relational diagram allows you to visually see how your database connects to each other, how each tables in your data connect to one another. So it depicts the various entities. When I say what do I mean? What? Entities. What are entities? What are entities? Object or table. So it depicts the various entities, their attributes. You know what are attributes? We talked about this when we there's also another word. In a table, what are the attributes? Column. So they are columns. Column that is the attribute. Right? Those are the things that describe the table more. Let's say another table. The other idea is a column describes each unique item to the table, the other name, and so on and so forth. So the relationship between them, providing a clear understanding of the data organization. Right? The ERD allows you to visually see how each table connects to each other. That's the ERD for you. And if you are going to do any form of database development, you are going to need to draw out your table structure. Because most database do not just have one table. You don't normally have one. They tend to have one or more tables that connects to each other. So, what is an ERD and why is it used? An ERD is used for data modeling, entity relationship, and design and implementation. An ERD is a data modeling technique used to visually represent the structure of a database we talked about. It allows you to show the relationship between two tables. I can say this table, show how this table connects to this table, how this one connects to this one, the connection between each and every one of this. So we'll talk about it, go deeper into this. Keep this one on the floor first. Wait for my laptop. Okay. So it also allows you to design and implement a database, right? Like they say, if you want to build a house, you don't just go there and start laying bricks, laying blocks. You have to have a plan before you go and do your foundation, and from there you start doing what you have to do. So the EDR is more or less a plan of your database. You have to structure how the database will be for that particular organization. Let's see. Okay, let's go back. So when it comes to creating your EDR, there are ways to actually draw out your entities, your attributes, and so on and so forth. So the first method is called the change method, right? These are change method have its own unique way of representing tables, attributes, and relationships. So this is the change method. This is also a change method. This shows the relationship between the employee and the department, with the manager being between them, and the one-to-one relationship. But we are not going to focus on this change method. Alright, so I'm going to focus on the more popular one. The other one we have is the UML, but the one we focus on is the pro-foot notation. It's a way of showing the connection between two or more tables inside of a database. Right? So this is how you use the pro-foot notation. This line shows the connection between two entities. This one is one, many, one and only one, zero or one or many, zero or many. We should talk about when we start doing our example. Okay. So when you are creating an ADR, there are some components of your ADR. First component is your entity, which is your table. Second component is your attributes, which are your columns. Next component is your relationship. So what connects them? Are they connected directly? Are they connected through a proxy table, and so on and so forth? Then the last one is your cardinality, right? Which is if they are connected one to many, one to one, and so on and so forth, which we talk about cardinality on a separate note. Okay, so this is your table, this is your entity, this entire box is your entity. This right here are your attributes. This line that connects this to this shows relationship. That this and this are connected. And these symbols here, this symbol here, shows the cardinality between these tables. So let's go into each of them and understand what they are. So what is an entity? An entity is a very important concept in a database. Right? It shows, it depicts a real value in reality. So let me read this up first. An entity is an important. Hello? So an entity is an important concept in database design. It's essentially anything in the real world that we want to store information about. Okay? Let's say anything in the real world I want to store information about might be, let's say, a book. A book is an object in the real world. You want to store information about a particular book, right? So an entity is mostly it could be a person, a place, a thing, an event, or a concept that has specific character. So let's say a book, you want to store information about the book. What are the characteristics of the book? It can be, you also have an ID to record each of the books. You can see the color of the book, and what else, the name of the book, the author of the book. So those are attributes. Is an object, right? Is a real world object that has different characteristics. So an entity normally just store information about a real world object. For example, another example is an organization, the students. Student is a person, right? The information about the student. So the student itself will now be the entity table. Then the information about that student will now be each of the attributes of the columns. So in relational database, you typically represent your entity as a table. So for instance, an employee entity will be called an employee table with columns for each attribute, like employee ID, name, position, hire rate, and so on and so forth. So when you are creating a database and you want to start creating tables, you look at the information that you were given, right? You know, okay, this information I'm talking about, let's say, the store, right? That's the place. So you want to store information about the store ID, store location, store name, and so on. Talk about staff, that's the person, right? Store information about the staff name, so on and so forth. You talk about customer, you talk about orders. Order is a concept, right? Let me call it a team, right? Call it a team, another is a concept or a thing. So and so on and so forth. So each of the components of that business that you want to store information about, objects about that, those real world objects about that business, you can create a separate table for each of them, then find a way to link them together. So an attribute is the characteristic or piece of information that describes an entity in a database. Okay, so these are specific details about any entity or table. So an example. An example of an entity in the, let's say, products. An example of the attributes in the products table would be the product ID. That is something that describes the niche product, an ID. That is the name, price, and so on and so forth. So what is a relationship? Right? The relationship component of an entity relational diagram represents how entities in the table are connected to one another There are some situations where you see this table is connected to this table, right? And this table might be connected to another table. So the relationship will be this table is only connected to returns, and returns is only connected to maybe there's another table. But this other table is not connected to that returns table. So there's no relationship between these two tables. Just imagine the table here. The relationship between these two, but there's no relationship between these two, but there's no line. It's not line that fits relationship. If there's a relationship between two separate tables. When you see the line, you know that okay, these two are connected in one way or another. So the importance of your relationship in India, they help visualize how data is connected. They define how entities work together to maintain a flow of information in database. They ensure that data consistency and reduce redundancy by linking related information. Let me explain what redundancy means. I talked about when we were talking about it. Let's say I have a big table like this, and in this table I have, let's call this. I have a order ID, it's called book ID, order ID. I have the order name, it's called price, order ID and order price. I have products, other information if I have a product in the category. Let's say this scenario, I have another, right? If I ordered one order, then I apply to the same product to iPhone 16. Another guy comes in to $10, but he also passport and phone. These are two separate people. So 10 guy comes, buy the same iPhone 16. So you have seen this iPhone 16 is being written multiple times, right? You can as well just say, okay, instead of having this review entered multiple times, you can create a new table for just products. So this table will now have the products ID and products name. The process of having one single information repeating itself is called redundancy. I mean, why are you putting it redundant when you use redundant? You have a product and then you have only one iPhone 16, but you have your own one ID. So you find a way to connect these two using the foreign key and connect this table to this table. So in this scenario now, you don't have to write this same and multiple times, just to get this. And this saves space in your databases, saves space. Redundancy makes your database slower. Imagine you have a database of 2 billion rows, and you have a repetition to make the database slower. That's the reason for data modeling, right? And India to help you structure your data in a way that is faster and more efficient and remove redundancies. So cardinality is one of the key points I will talk about here. Cardinality in database design describes the number of instances of one entity that can or must be associated with the instance of another entity, which is a bit confusing. Right, so let me explain it with this. Let me use this one. I can use this. Let me use this. So, if I order so if I order, let me say I order an iPhone, the order ID for that is order ID 1, right? And I want to return the iPhone. Right? This simply means, and if I return the iPhone now, can I return the same iPhone multiple times? Only once. So cardinality simply means the So it simply means the number of times this other entity, right, can happen with this return entity. Let me break it down. So for my iPhone example, if I order one iPhone, right, the relation between the iPhone, the order, and the return is 1. And only one iPhone, I can order one iPhone. Sorry. There's a better example somewhere. Use this. Okay, it's not here. Let me just want to explain it. We'll go back to that. Let me explain all of this, all this concept. So this first one, it means that the relationship between, let me use this order and return, for example. If I put this one dot, it means this order, one person can order, right? And that is the order. Check. I think I have a better example. Come in. Just give me a second. Since I didn't write it out, to write it out, to write it out. I don't think I have it saved. It's not here. Let me draw it. So the cardinality shows how this, let's say this is our origin entity, this is our target entity. So when you are connecting these two tables together, the cardinality you use, if this is your origin, so this is where you are starting from, this is your origin, so this is your target. And you want to do the cardinality between these two. You are going to focus on one further away from the origin, this one. This is what you focus on. And what does this symbol stand for? This one stands for 0 or many. Let me explain what 0 or many means. It simply means that one book can have 0 reservation. That means nobody might reserve a book and say they want to keep it, they want to buy the book later, they want to read the book later. 0. One book can have 0 reservation. That means 0 people can reserve the book. Or this is the same one book, many people can reserve it. So the relationship between this book and this reservation is 0 to many. Let me draw a table for it. Let's say let's call this book. I think I'm going to stretch it down. It's a book. I'll just call it C. R. This book now, this is the book. The book name book I did. This book might be reserved by nobody. So when I'm joining these two tables together, I have a situation where I've been putting like I said, the relation between these two can be is 0 or many. So in a situation where nobody reserves this book, when I join this table together, I'll get an empty table. Okay? So when it's 0 or many, when it's many now, this one book, I have one book, you can go reserved by ID number 2. The same book again. 1. You can go reserved by ID number 2. I mean, different people can reserve one book, or nobody can reserve one book. So the relation between these two tables, just by looking, you know that either one person reserves the book, nobody reserves the book, sorry. Either nobody reserves the book, or many people reserve the book. That means many reservations for one book, or no reservation for that book. That's the reason we say this entity and this entity. So you can also switch your targets entity and your origin entity. So let's say this table is not the origin, this table is not the target. You want to know the connection between this table and this table. Right? So this symbol stands for 1 and only 1. When you have this 1 and only 1, it means that one reservation can only be for one group. One reservation can only be for one group. Say I reserve and I get the ID of 1. That 1 is only for one group. So this 1 and only 1 group. The relation between this and this is that if I have one reservation ID, which is a unique reservation, for just one group, that's what this one means. But this one, I can have a reservation for this one group, right? Many people can reserve this one group, so I can have observation ID for 1 foot. That's what it's coming. This solution quantification. But if I'm moving from here, this is my origin and this is my target. It means, and you see this dark, means one is observation for 1 foot.